then we can begin. Let me just share my screen as well. Okay. Sorry guys for the delay. So let's begin. All right. So hi, my name is Tvish Sangvi. I'm a tutor at the Fulton Engineering Tutoring Centers, known as the Pulse. Um, Here you can see. So this is the exam 3 review for Calculus 2 or Math 266. All right. Let's get started. You can So the review that I'm going through, you can find the link for that right here. You can see it's also on the website of the School of Mathematical and Statistical Sciences. You can As they have highlighted here, you can find the exam review. All right. Okay. Let's begin with how to set up Math 266 exam problems. So the very first step that we recommend is read the problem slowly and circle the givens and what you're asked to find. Define your variables, and write the function or equation that models the situation. This is just to give you a clear idea of what you are working with. And also include the domain and any units if they are important. For example, if you are asked to find, let's say, volume in any of the questions, you need to remember if it was in centimeter cube, meter cube, or feet cube, or anything else, right? Okay, your calculator must be your friend. That's the most important thing. So set it up in a way that is intuitive for you, and I would suggest do that a day or two before the exam so that it's helpful and you also have a bit of practice with that. And also make sure you practice, as I said, yeah. And also interpret your answers in context, check the units, state your conclusion in words, and see if your value is reasonable so that the professor also have a good idea that what you're doing in case you have a lot of scribble work. So the professor, the grader might have a better idea of what your final answer is. All right. And also at any point, if you all can't hear me, just let me know or speak up. It's all right. I'll try to fix the issues. Okay. So let's start with the problems. Okay. So the first one, I've kind of done it earlier. So let's see. It's considered series summation n is equal to 6 to infinity n plus 9 to divided by n factorial, and they have asked us to find the limit n tends to infinity a n plus 1 over a n. So first, as what we do is let the general term be a of n or a subscript n, which is n plus 9 divided by n factorial. So this term that I'm talking about, right? And now, so we first now compute the ratio of the nth term, which is just this term right here, and the n plus 1th term, all right, which is kind of here, as you can see. So we have to first take the ratio to find this quantity right here, all right? So the n plus 1th term is just adding plus 1 to the to all the n terms. So here in the numerator, we add n plus 1 plus 9, and in the denominator, we add n plus 1, the whole factorial, right? Okay, so now we take the ratio of that. As you see here, we have taken that. And now, if we shift around the values a bit, we get this answer, n plus 10 times n factorial over n plus 1 times n plus 9. So now, oh, okay. Um, yeah, that was expected. Sorry for that. All right. Um, yeah. Okay. So now we will compute the limits. So we were asked to find what is the limit at n tends to infinity. All right. So limit n tends to infinity was n plus 10. Okay. Oh, I guess there's someone in the waiting room. Um, yeah. Right. Sorry for that. So now we will take the limits, as I said, and when if you look at it, we have a factorial term in the numerator and also n terms in the denominator, so that will tend to n square if you open up the brackets. And we cannot really get rid of the n here. So when you apply the limits, that is gonna eventually converge to 0. So the answer for this question will be 0, right? Okay. If you have any questions, just let me know, or otherwise we can move to the next question. Okay. So for the next question, have to determine whether the series n dot n times 5 raised to the n divided by 3 raised to 2n plus 1 is absolutely convergent, conditionally convergent, or divergent. All right. So just a quick note here. This is an entire exponent term. All right. Okay. So let's start with it. So first of all, let the general term an is equal to n dot 5 raised to n divided by 3 raised to 2n plus 1. All right. So a n plus 1 term will be n plus 1 times 5n plus 1, entire thing divided by 3, 2 times n plus 1. So look here, it's in bracket 2 times n plus 1, right? Plus 1. Okay, so now we'll compute the ratio of these two terms. So a n plus 1 divided by a n. All right, so let's see what we get. So we get n plus 1, 5n plus 1 divided by, okay, yeah. Yeah, this one, my bad. This term will not be like this. This term is just, let's see, we'll have, yeah, 2n plus 1, and this term will be 5n plus 1. Oh, yeah, that was right. Okay, so divide by 3, 2 times n plus 1 plus 1 multiplied by, so I'll just flip this. So it's a multiplication instead of division. So we get 3 times 2n plus 1 divided by n dot 5 raised to n, right? Okay, so now if we try to solve this, we'll get an answer of, let's say, 5 times n plus 1, okay, divided by 9n, all right? Okay, so now I can take out n from this, and this will give me an answer of 5 by 9. It's just I've taken out n and applied the limits. All right. Basically, it should look like this 5n. So 1 plus 1 over n. Okay. So n and n gets cancelled. And if you apply the limits, and n tends to infinity, so 1 over infinity is 0, which is written as um, limit n tends to infinity 5, 1 plus 1 over infinity over 9. So this term goes to 0. So we have 5 by 9, which is less than 1. All right. So this series converges absolutely, right? Okay. So the thing is, if it was more than 1, then it was divergent. And if it was like 1, it would have been conditionally convergent. But again, there are different variations to it. That if you have another question, we'll get to that later. But for now, so this is the answer. Again, if anyone has any questions, please let me know. Otherwise, we'll move on with another question. Okay. All right. So the next thing that we have is find the largest open interval of convergence and the radius of convergence for the term 3x raised to n over n factorial. Again, this term is more or less the same, but let's see. Let's try to do it. So again, the general term an is equal to 3x raised to n divided by n factorial. All right. So now, again, my n plus 1 term will be 3x n plus 1 entire thing divided by n plus 1 factorial. We'll take the ratio again, the same old thing. So the ratio will come out to be 3x divided by n plus 1, right? This is just I've just basically cancelled out some terms. You all will be pretty comfortable to do that by now. We have already done that in the previous two. So let's see. Now, If I apply my limits, so limit n tends to infinity, I will have 3x infinity plus 1, which in turn is just 3x over infinity, and anything divided by infinity is just 0. All right. So basically, what the question is asking us is what is the largest open interval of convergence? So from this, we can see that let x be any value, negative infinity to positive infinity. The answer that we will get is always a 0. So our largest open interval is from negative infinity to positive infinity, because as I said, it does not matter whatever value x takes, it's still gonna converge to 0. So that's why this is an open interval. And the radius of convergence is also infinity. All right, this is equal to r. Right. Okay. Uh, basically, we just apply the formula of the circle or theory of the circle. So basically, let's say this is my center, and the diameter was negative infinity to positive infinity. So my radius is just half of it, which is infinity. All right. Okay. So let's move on with another question. Okay. Again, this is a similar question. I believe you all can do it. Just looking at the previous one, it's the exact same steps that we follow and the exact same way how we find the open interval and the radius of convergence. So we'll just move on to the next one for now. If you have time, we'll again get back to that. And if someone wants to practice that, please put that up in chat box. I'll try to take a look at it again. Okay. Okay. So moving on to section 8.6, we have find the power series representation of the function f of x is equal to x squared, the entire thing divided by 2 plus x, for the absolute value of x less than 2. All right. By using the fact uh, that 1 over 1 minus x is this. Okay. So let's keep this fact in mind and let's see what it does for us. Okay, so let's just write f of x. I'll just increase my font size. So I have f of x is equal to x squared 2 plus x. Right? Now, uh, I'll just write it in some different terms so there's no confusion. Okay, so I will use 1 over 1 minus u is equal to summation of n is equal to 0 to infinity u raised to n. Right? Again, for absolute value of u less than 1. All right. So basically, this value will be like 0 to 1 because we are using an absolute function here. So let's write it in the given form. We will have 1 over 2 plus x. I'm just writing it, trying to write it in a general format like this here, is equal to 1 by 2 dot 1 by 1 plus x by 2. I just took 1 by 2 common out. And now we will have 1 over, so 1 by 2 times 1 over 1 minus negative x by 2. So as you see, we have got this in a general form like this one here, right? So now the next step will be for the summation part, right? Let's see. So we have 1, 2 plus x is equal to 1 by 2. N is equal to 0, infinity, and that this will result in u raised to n, and our u term here is negative x by 2. All right, so negative x by 2 raised to the value of n times x squared. We cannot forget our numerator, right? So times x squared. So this will give me summation n is 0 to infinity negative 1. I take it common. This will also be raised to n. Then we will have x raised to n plus 2. These are some indices rule or exponential rule, you may say. If we multiply two base, like if the base is same, the exponents just get added, all right? If they're getting multiplied. All right, divided by 2 raised to n plus 1. All right? And here, we know that the absolute value of x is less than 2. So this was given us, right? So that's it. This is the only thing that you have to do, right? This is my power series right here. This was the only thing that they asked. Okay. Any questions about this? Take it in. This may look a bit abstract, but trust me, once you try solving this, it'll be much more intuitive. Okay. So let's see. Next question. Now, find a power series representation of f of x is equal to ln 1 minus x. And again, they have given us a hint that ln 1 minus x is just the integration of -1 divided by 1 minus x dx. All right? Okay, so let's try this one. It's a nice question, to be honest. So let's see. So we have f of x is equal to ln 1 minus x. All right? Now, with this identity that they have given me here, I can write it as d over dx ln 1 minus x is equal to d over dx integral -1 minus x dx. So this will just result like the derivative and the antiderivative just cancels out each other, and I get -1 over 1 minus x. This also cancelled. Okay, so let's see. Now, our standard form from the previous question, if you remember, was 1 minus x is equal to n is equal to 0 to infinity x raised to n. This was our power series formula. The absolute value of x should be less than 1. Okay. So now we have -1 divided by 1 minus x. So let's get the negative sign outside, and we get summation n is equal to 0 to infinity. And again, x raised to n. That's the only thing that we have. Now, let's integrate it term by term, right? So now I have ln 1 minus x, remember, from the starting of the question. So we have negative summation n is equal to 0 to infinity x n plus 1 over n plus 1 plus some constant. This is just basic integration of x raised to n that I've done, which should look like xn plus 1 divided by n plus 1 plus some constant. This is what we have done here. All right. Now, since ln 1 minus 0 is equal to 0, like, for example, let x is equal to 0. So ln 1 minus 0 is just ln of 1, and ln of 1 is equal to 0, right? This is the property of natural log. Therefore, my c will also be 0. All right. So now we have basically ln 1 minus x is equal to negative n is equal to 1 to infinity x raised to n over n, given that absolute value of x is less than 1. Right? Any questions about this power series formula? This one or the previous one? All right. So moving forward, we have find the first three non-zero terms of the Maclaurin series for f of x is equal to 1 minus x raised to the power of -2. Okay. So for the Maclaurin series, we have the formula. Like for this, we will have 1 minus x raised to the power of -2 is equal to, again, n is equal to 0 to infinity n plus 1 times x raised to n. This is like kind of a general form of the Maclaurin series. So this results in 1 plus 2x plus 3x squared plus 4x cubed plus so and so, and go on forever till it converges. Okay. So what they asked us is for the first three non-zero terms. So we can see this is these three are my first non-zero terms. All right. So that will be answer 1 plus 2x plus 3x squared. Okay. Uh, that's the only thing that there is for Maclaurin series. We just use this formula right here, and Following this, we calculate the values. For example, n is equal to 0. So for the first, let's go term by term. So term 1, we have n plus 0, because 0 was our starting point. X raised to 0. So this will be n. X raised to 0 is just 1. So n, and we just give it as 1, the coefficient. Because in the series, you are just looking for the coefficient, right? Okay. For term 2, I have n plus 1, x raised to 1. Okay. So here, okay, yeah. Right. This was about 0 plus 1. This wasn't there. So x is 1, and here we have 1 plus 1, x raised to 1. So we have 2x raised to 1. And for term 3, we have 2 plus 1, x squared is equal to 3x squared, as you can see. And we can go on forever and forever for this. So that's the basic logic for Maclaurin series. Now, moving forward, let's see what we have. Okay, again, a Maclaurin series question. It's kind of different, but again, it will follow the same logic that we had. So they're saying that a function f of x has a Maclaurin series on -1 to 1. If possible, find the first three non-zero terms of Maclaurin series if f of 0 is equal to 0 and the first derivative of f at 0 is equal to -1 and the second derivative is 4 and the third derivative is 6 and so on. Okay, so we'll first write the something called the Maclaurin polynomial. Okay, so the Maclaurin polynomial gives us f of x is equal to f of 0 plus f of 0 times x plus f of 0 x square times 2 factorial plus f of 0 times x cube over 3 factorial and so on. If you see, it's kind of using the same logic from the previous question that we had. Basically, it was like n plus 1 times x raised to the n, summation from 0 to infinity. So it's kind of following the same rule if you see. Okay, so let's put it in action. So we have f of 0 was 0 plus f of 0. Okay, yeah, this one's. So this let's see, this will result in 4 by 2 x squared, then we have 6 by 6 x cube and so on. So you can just simply write it as 2x squared plus x cube and so on, right? So just follow this pattern and you'll get to your answer, okay? And yeah, this should have been derivatives, my bad. Okay, so f of 0 was 0, f dash of 0 was -1, it got converted, and then so on. All right. Okay, so let's go ahead and see. So yeah, so we got our first three non-zero terms by just having one more value here, and you'll get the answer. Okay, let's see. There is again 0 plus -x. So -x. Okay. Oh, this was this term right here because f dash of 0 is -1. So -1 times x is giving us -x. All right. Okay. So any questions for this one? Are you good? Anyway? Okay. So let's move on with the second set. Okay, again, use the known Maclaurin series for sine of x to find the first three non-zero terms of the Maclaurin series of f of x is equal to x sine 3x. Okay, so we know that sine x has kind of given general series which is like this: x minus x cubed by 3 factorial plus x raised to 5 over 5 factorial plus so on. Okay, So follow the same fashion, and even if they ask you for 5, 6 terms, you can still uh, use this and like incorporate it into your solution and get the answer, right? So now we let's take sine 3x first to make it simpler. So I have sine of 3x is equal to, I'll just multiply 3 everywhere as a coefficient of x. So 3x minus, uh, okay, I will have 3x cubed by 3 factorial plus 5x raised to 5 over 5 factorial and so on. Okay, so if we solve this, we'll get, for example, 3 cube gets 9, and then 3 factorial is, uh, let's say 6. So yeah, you get the idea, and you can just solve this. But again, if you see, we have an x term. So for that, let's see what we can do. X sine 3x. So what we'll do is just multiply x to each and every term. So I will have 3x squared minus 9 x raised to 4 by 2. I'm just adding, multiplying x to each and every term like this. Nothing else. Plus, this will give us, let's see, let's calculate. This will give me 81 over 40 x raised to 6 and so on. Okay. And these are your first 3 non-zero terms. And that's your answer for this question. All right. Moving on. Use the known Maclaurin series for e raised to x to find Maclaurin series for f of x, x squared, e raised to 3x. Okay, so let's see. This is also kind of the same for, we have kind of given Maclaurin series for e raised to x, so we'll just follow that with e raised to 3x. So e raised to 3x will be 1 plus 3x plus 3x the whole squared by 2 factorial plus 3x cubed by 3 factorial plus 3x raised to 4 by 4 factorial and so on. Okay. Now, the thing that I've asked us is x squared e raised to 3x. So again, I'll just multiply x squared everywhere. So I'll get x squared plus 3x cubed plus, let's say, sorry, this is supposed to be plus 9x squared times 2 is 4 divided by 2 plus 27x raised to 5 over 3 factorial is, let's say, 9. Let's keep it like this. Okay, and so on. Okay, and we're going to keep going. So if you're asked to find the first 3 terms or first 5 terms, just use the series and you'll get the answer. Okay. So basically, looking at this, we can try to get it into a formula, for example. That's what the question is asking us here. So x squared e raised to 3x. By looking at the terms, what you can see? That it's just a summation of n is equal to 0 to infinity as it's going on and on. 3 raised to n divided by n factorial x n plus 2. This plus 2 is coming from this x square. All right. And this 3 is coming from the 3 here, the coefficient of x, right? And that's how we solve this. All right. And that's the final answer for this one. Okay, moving on to the next section. So we have section 9.1. All right. Any question? I've not checked the chat box in a long time. Okay, yeah. If you have any questions, please feel free to ask in the chat box. Okay. All right. If no one has any questions, let's start then. So here we have to eliminate the parameter to find the Cartesian equation for the curve represented by x is equal to root t, y is equal to 4 minus t. Okay, so my x is equal to root t, y is 4 minus t. Okay, so from this I can see that my t is just x squared, and so my y will be 4 minus x squared. Right, I'm just using this value here. So, and you can also see, since my x is equal to root t, t has to be greater than or equal to 0, because a negative number inside a square root function is an imaginary function, and we're not dealing with that here. Okay, that's not a dual value. So basically, my Cartesian product is just 4 minus x squared, and the value of x should be greater than or equal to 0. Okay, all right. So if you have no questions about this one, we'll move on to the next one. So it's a fairly simple one, but just something to remember about the properties of square root. Okay. Now, they're asking to describe the parametric curve for the set of parametric equations x is equal to 5 cos sine t, y is equal to 2 sine t, from 0 to 2 pi, including starting point, the terminal point, and the direction. All right, so let's just write down the parameters. We have x is 5 cos sine t, y is 2 sine of t, and we have 0 to t to 2 pi. Okay, so let's try to eliminate t. I'll just bring x over 5 is equal to cosine t, as if I brought it here, and same here, I'll have y over 2 as sine t. Okay, so if I square these terms, let's see what we get. I get x square over 25 is equal to cosine square t, and y square 4 is equal to sine square t. Now, if we add these two property these two values, x and y, I get x square over 25 plus y square over 4, I get cosine square t plus sine square t. And, if you remember the algebraic properties or the trigonometric properties of sine and cosine, if we have sine square plus cosine square, we just get 1. Okay? So x square over 25 plus y square over 4 is equal to 1. So if you see, this is the formula of ellipse. Okay, and it is centered at origin, right? Because there is nothing added or subtracted to x or y. Okay, that means that it's located at the origin. So now let's see, at t is equal to 0, that means at y is equal to 0, I'm just putting y as my t point. So I will have x comma y is equal to 5 comma 0. All right, because we have set the relation right here. Okay, this is like saying that x is equal to 5 cosine 0 gives me 5, and y is equal to sine 2 sine of 0. This gives me 0, right? So from here we get our answer. All right, now at t is equal to 2 pi. So basically these two are the bounds that we had. So let's see. I will have x is equal to 5 cosine 2 pi, and y is equal to 2 sine 2 pi. Okay. So here again, 5 cosine 2 pi will again give me, 5, and y2 sine 2 pi will give me 0. So my x and y value again are 5 and 0. Okay. So basically it's saying that as t increases, the curve. Oh, all right. Wait, I made a calculation error. Sorry, my bad. It's 2 pi, not pi. So it's 0, and this is 2. 0 and 2. Okay, my bad, guys. Okay, so basically this is saying that as t increases from 0 to 2 pi, the curve moves from 5 comma 0 to 0 comma 2. All right. For example, if we have a coordinate system like this, okay, so at first, let's say this is my x and this is my y. So first I was, let's say this is 5, this is 0, and this is 2. First I was at this point, and then as my t increases, I'm kind of shifting towards this point here, right? Okay, that makes sense. Let's start. And as you can see, it is moving in the counterclockwise motion if they ask you for the direction. All right. Okay. So let's see the next question. It's like from section 9.2, we have find the equation of the line tangent to the graph of the parametric curve defined by x is equal to t cosine t and y is equal to t sine of t for t is equal to pi. All right. Let's write our equations. We have x t cosine t. I have y t sine of t and t is equal to pi. Again, this is kind of like finding parametric equations. So let's plug in the value of t. We have pi cosine pi, y equal to pi sine of pi. All right. So x will be negative pi and y will be 0 as cosine of pi is negative 1 and sine of pi is 0. All right. So my point is, so the point at P is negative pi comma 0. This is my Cartesian point. Now let's find the slope of it. Slope formula is dy over dx is equal to dy over dt divided by dx over dt, right? So let's calculate first. Dy over dt is equal to sine of t plus cosine of t. We get two terms because of the chain rule. All right. And dx of dt similar in a similar fashion, we will have cosine t minus sine t. All right. Okay. So at t is equal to pi, we will have let's see dy over dt is equal to sine pi plus cosine pi. So we will have sine of pi was 0 and this was, oh, this was my bad. This should have been t cosine t, even here. Okay. And for the top part, it should have been t sine of t. Right? Okay. So I have pi times negative 1. So this gives me negative pi. And for dx of dt, I have, let's see what we have. Cosine pi minus pi sine pi. So this gives me cosine of pi is just negative 1 and this will be negative pi times 0. So I just get negative 1. All right. So my dy over dx is equal to dy over dt, which is negative pi divided by negative 1. So this gives me pi. So the slope is pi. All right. So we have found the slope and we'll use the slope point form, which is mx plus b. So from that, I get y minus 0 because that was my first point that I calculated at. And the second point will be like my pi. So I calculated that slope as b times x plus pi. Okay. So this gets y is equal to pi times x plus pi squared. All right. Any questions about this? I just want to clarify about the derivative that we for dy over dt, it should have been sine t plus t cosine t, and the for dx dt we have cosine t minus t sine of t. All right, here you can see. All right, so we are done with this question. This is your final answer right here. If you have any questions, please let me know. Okay, so looks like this is the last question for our review today. So let's see what is it given. If a projectile is fired with an initial velocity, so If anyone of y'all have taken physics this sem or previous sems, this may be kind of familiar to y'all. So this is like a projectile motion. Okay. So my initial velocity was okay, they haven't given. Let's see. Disregard this. Okay, if a projectile is fired with an initial velocity of v naught at an angle of alpha, so this angle is called alpha, above the horizontal, and air resistance is assumed to be negligence. So the air resistance here, or the friction, is set to be zero. Then its position after t seconds is given by the parametric equations here. Okay, where g is the acceleration due to gravity, alpha is the angle of elevation, and v naught is the initial velocity. Okay, so the first question is find dy over dx. All right. So, first of all, let's rewrite our equations. So x was, let's see, v naught um, cosine alpha t, and my y value was v naught sine alpha t minus half gt square. Okay, so to find dy over dx, again, we'll use the same formula, dy over dx. We are doing parametric differentiation here. We have dy over dt dx over dt. So let's see. I have dy over dt as, we'll first differentiate. Let's first differentiate dx over dt. Uh, sure. Okay, so dx over dt is given as just v naught cosine alpha, right? And for dy over dt, we have v naught sine alpha minus 2 into 1 by 2 gt. This gets cancelled out. So dy over dt is v naught sine alpha minus gt. All right, so let's calculate our dy over dx, which was just dy over dt over dx over dt. So I have v naught sine alpha minus gt divided by v naught cosine alpha. You can just leave this equation right here. That's the only thing that I have asked. You don't need to simplify this anymore. Okay. Now let's see what they have asked in part B. Suppose a projectile is fired with initial velocity of 100 meter per second, because we know it's an initial velocity, at an angle of alpha is equal to 60 degree. At what time does it reach its maximum height? So we are talking about this point here. And okay, let's just reiterate. So this is my distance. Let's call this x. And time is also for moving forward linearly in this case. All right. So round your answer to the nearest tenth of a second. So we are going for height. So the most likely we'll be using y-axis if you have set that coordinate like that. Let's just draw a frame of reference. So this is my y-axis and this is my x-axis. So so it's clear and there's no confusion about it. So if you remember from the first step, I had my dy over dt set up as v naught sine alpha minus gt. And this should be 0, because when we are at this point right here, let me use another color. When you're at this point, if you see, the slope is 0. Okay, it's kind of the like when you reach the maximum velocity, or sorry, the maximum height, you tend to see that objects seem to take a pause and then start to dip. That's this point right here. Okay, that's why this is equal to 0. Our slope is equal to 0. So let's just reiterate it. V naught sine alpha minus gt is equal to 0. So we have everything given to us except t. We just have to find that. So let's fill in the values. So v naught was 100 sine 60 degree minus 9.8, t is equal to 0. You do not really have to care about the units because the equations are already given by them, and uh, this kinematic equation is going to result in time. So it's fine if you don't write the units here. Okay, so 100 times sine x, uh, let's just write it like this. T is equal to 100 sine 60 degree divided by 9.8. All right, so this gives me 100 sine 60 values root 3 by 2 divided by 9.8. And if I put this into my calculator, I get approximately 8.8 seconds. Okay, so this is the solution for the last question that we had for today. All right, any of y'all have any different questions about some uh, logic of what we have solved, or any theoretical questions that you may have? It might be the perfect chance to ask for it. And again, while you are going through the review, and if you don't understand something, we are always open for walk-ins. We don't need any appointments as such. Y'all can just drop in anytime between Monday to Sunday at the Pulse Tutoring Center, which is at ECG 152, and ask for our tutors. They will be able to help you out with any review questions that you have, or any theoretical or knowledge gaps that you have before the exams, and will be able to help you out in a much better way, so that you will be really prepared for your exam. All right. Okay, so we still have a bit of time left with us. If you all want, I can go back and solve the power series question. If you all still have the doubt about that. Anyone has any requests? If not, this is the end of the review session for today. I'll just hang out in the Zoom room for a couple of minutes, and if you all don't have any questions, I'll just end the review session. All right. I hope this was helpful for you all, and all the best for your midterms and also for the finals that are coming soon.
Uh, Hello?
Oh, hey Dante. I hope that I pronounced your name right.
Excuse me. Hello.
Yeah,
Yeah,
I
it
can hear
did.
you.
You really did help. I had a question about
Yeah.
the ratio test that you did first. Can you hear me?
Uh, yeah, I can hear you. So, which question are you talking
Okay.
about, if you remember?
I had a question about the ratio test that you did when you
Okay, let me just scroll
simplified the
back to.
exponents that contained n.
Hmm.
Uh,
Okay, let
I
me
just
just
wanted to
scroll
be a
back to
little
it.
bit more sure about how
Yeah.
you did that.
Okay, let's try the first question. Okay. So, okay, let's look here. All right. So, as a
Right,
general
right.
term, I first write whatever was given you. Let me just erase this real quick. Okay. So, the general term is basically whatever they have asked you to sum, like for the summation part. Okay, basically this part is my general term. All right, so that's my a nth term. Moving forward, we will add one term to the a nth term. So basically a n plus one. So wherever you see an n, just add one to it. All right. So we have n plus one times 5 raised to n plus one. Then we have, I know this is not really clear, but this is 3 raised to the power 2 times n plus 1. Okay. And now we divide these two. Okay. So I guess your question is about this simplification right here.
Yeah, it was because I'm good up to the
Mm-hmm.
point where you keep change flip and then
Okay.
you plug in the n plus one. But I got a
Mm-hmm.
little confused because this one contained n with the
Mm-hmm.
exponents. And when you finished, because I got
Mm-hmm.
a final answer of 1/3 times 5 divided by, sorry,
Mm-hmm.
1/3 times 5 times the 1 divided by
Um,
n.
will it be possible for you to put that in the chat box maybe? So I can take a better look at it. There may be some
Yeah,
calculation
I
mistakes
got
that
you.
I might be done. I'm happy to look at it.
Roger.
or let me know once you're done.
Sorry, that last limit would actually just be one. So you could just ignore that.
Um,
But that was what I ended up getting.
okay,
I don't know how you
with
got nine.
9.
I
Wait,
just
you're
yeah.
for
So I'm looking at your like you have five over. Obviously, you have your limit 5/9 is less than
mm-hmm.
one, so that's absolutely convergent. I don't know
Yeah.
how that three turned into nine in the denominator.
Okay, so basically here if you see there's a 3 squared term. That's why. Okay, for example, for exponents, if you have x raised to n divided by x raised to n plus 1, this just gets converted into x raised to n minus n plus 1. All right. So we will have x n minus n minus 1. So this just becomes x raised to negative 1. I know it's not the same exact thing that's happening here, but it follows the same logic.
Okay.
Right. If you want, I can just try to show you the complete solution if you'd like. Or we can just try another question and I'll show you all the steps for it. How to simplify, if that helps.
It helps. It definitely helps.
Okay.
I'm pretty good with these. It's just this one kind of threw me off
Again, there may
with
be
the
some term that I
exponent.
may have not looked over, but again, general idea is the same. Uh, Again, for these type of questions, if your logic is right, professors tend to give you like a benefit of doubt by saying by looking at each and every calculations and give you partial credits. So the important step is show all your work right here. I know I have not done that here due to time constraints, but again, it's a nice strategy to just explain your entire work. So even if you have messed up on a sign or some exponent, you still get a lot of partial credit for that question. All right?
I literally just as you were yeah, I think
Mm-hmm.
that's great as well. And as you were speaking, I just realized why that
Mm-hmm.
exponent gets raised to nine.
Yeah.
I see it. Yeah.
Right. Like I'll try to explain it. This may help you. So we have 3 to n plus 1. I'm just taking this term and this term divided by 3
Yeah, that 2n
to
gets
n
ignored in the n plus
plus
one.
2 plus 1. All right? That's why.
Yep,
So this
exactly.
becomes 3 to n plus 1 divided by 3 to n plus 3. So if I have to convert this, I get 3 to n plus
Subtract.
1 minus 2n minus 3. So this gets cancelled, this gets cancelled. So I have 3 raised to negative 2, which I can rewrite it as 1 over 3 square, and that gave me 1 over 9 here.
Absolutely.
Okay? All right. Again, it's all right. Just try to give it give some more time to these type of questions, so you don't kind of make errors during the exponent parts. But yeah, again, if your core logic is spot on, I'm pretty sure you'll get it. All right.
Yes. Thank you so
Any
much.
other? I'm welcome. Um, any other questions? Anyone? Even if it's kind of theoretical, not in this review, we still have time. We can still go over it. Right? Okay. If no one has any questions, I would like to thank you all for bearing with me. I know we had some technical issues at the start, but yeah, again, I would like to reiterate that if you all face any issues from now till the time of exam, I would still recommend to please visit us at ECG 152 and take the benefit of free tutoring that we have for each and every student on campus. Right?
Thank you
Okay.
very much.
Thank you, sir. All right. So with this, I will end today's session. Thanks for joining with me. All right. Right, screen. Stop sharing. Okay.